I want to move on to similar polygons. So before we were writing out ratios and writing out different proportions and then solving those proportions. And we're going to now do that with similar triangles and find their sides. So, yeah. So similar polygons are polygons with the same shape, but not necessarily the same size. Okay, so similarity is different than congruency. So it will have that same shape, but your side lengths are going to be different sizes. Not one of those, because those are mine. Okay, the symbol for similarity is the squiggle here. Okay, so it's kind of like our congruent symbol without the equal sign. So it's just, huh? I didn't dye it. It's straight. So the definition of similar polygons. It's two polygons are similar if corresponding angles are congruent and corresponding sides are proportional. Okay, so with similar polygons, your angles are still going to be congruent to each other. Just your sides are going to be different measures, except they have to be proportional to each other. So in this first example here, if we have triangle ABC is similar to triangle XYZ, we want to list all pairs of congruent angles and write a proportion that relates to the corresponding sides. So a similarity statement is very similar to a congruency statement. So that would be what they wrote here. That's called a similarity statement. So I can write triangle ABC is similar to triangle XYZ. Now, just like when we had congruent triangles, they do have to go in that specific order. So if I start with A, then I start with X. Those two angles need to be congruent to each other. So if I'm listing my congruent angles, since I go from A to B to C, I know A has to be congruent to X. So I can write angle A is congruent to angle X. Then I went from A to B, and in this one, I go from X to Y. So that means B and Y have to be congruent. And then the last one, I go to angle C, and that one goes to Z. So angle C must be congruent to angle Z. Okay, so that's figuring out which angles are congruent. Okay, next it wants us to write a proportion that relates to the sides. So below there, I do have that proportion kind of laid out. So I have side AB over side XY. So I have AB here over XY here. So it wants it to its corresponding side there. So I have my first one over my second one. Then I have BC over YZ. So my last one then has to be AC over which side? XZ or ZX works as well. Okay, so it's that corresponding side in order to create that proportion. Okay, questions on example 1? All right, example 2 then. Example 2, determine whether the pair of figures is similar. So, if so, write the similarity statement. and the scale factor, and then explain your reasoning. So step 1 with a problem like this is to compare corresponding angles, because if it's a similar polygon, your angles have to be congruent. So if I look at angle W, it would be congruent to angle P. If I look at angle X, that would be congruent to angle Q. Y would be congruent to R. And Z would be congruent to S. Okay, so right now, after comparing my corresponding angles there, they do line up with each other for congruency. So therefore, corresponding angles are congruent. That's step 1. Okay, step 2 is to compare our corresponding sides with ratios. So I'm going to take my corresponding sides, WX over PQ. So WX is 12 and PQ is 8. And then I just want to reduce that ratio to get 3/2. I'm going to do the same thing with the next 3 sides. So I'm going to find side XY. So I have side XY, that's 18, over side QR is 12. And again, I want to reduce this ratio. Okay, so both of those numbers do divide by 6 to get 3/2. Same thing with YZ over RS. YZ is 15 over RS is 10. Okay, both of those divide by 5. And I do get 3/2. And then the last side I have ZW is 9 over SP is 6. Reduce that one again to get 3/2. So when you're trying to see if these are similar, you need to make sure your reduced ratio is always the same. So since corresponding sides are proportional, these two polygons are similar, and your scale factor would be 3/2. Okay, so that reduced ratio for all 4 of those is your scale factor. No. Okay, questions on example 2? Okay, so again, the scale factor is the ratio or fraction of 2 corresponding sides of similar polygons. Okay, so your sides have to be those corresponding sides. Write it as a ratio or fraction, and then reduce it to get that scale factor. Okay? Okay, then on the back, I'm going to, quiet please. I'm going to skip the top one and we're going to go into example 3. So you can use scale factors and proportions to find missing side lengths in similar polygons. Okay, so if I know that these 2 polygons are similar, I can set up a proportion ratio. I can set up a proportion, cross multiply, and solve for that missing value. So in example 3, the 2 polygons are similar. We want to find x and y. We want to use the congruent angles to write the corresponding vertices in order for our similarity statement here. So I have triangle RST is similar to triangle. If I started with R, I need to start with M. I went to S, so we'll go to N, and then finally to P. So M, N, P. So now we want to write out proportions in order to solve for x and y. So we're going to use our proportional sides from both of these triangles. So over here, what I want to look for is two corresponding sides that both have numbers, okay, that don't have a variable attached to them. So when I look at this, I notice RS and MN are corresponding sides, and they don't have an X or a Y within it. So I can write out my first ratio using that. So I could write out 32 over 16. Okay, so for this one, since I started with the larger triangle and then went over the smaller, it has to line up that way again. So I need to start over here. So I'm going to solve for x first. So that means my x value has to go on top of that proportion because I started with 32, went over 16. So now I need to start with x, and it has to go over its corresponding side, which would be what? 13. Okay, and once we set up that proportion, all we have to do now is cross multiply like we were before. So I'm going to multiply 16 and x and 32 and 13. Okay, and then I just need to divide by 16, and I do get x is 26. Okay, now I want to solve for y. So I'm going to use that same ratio of sides that I had before. So I had 32 over 16, but now I want to solve for y, which is right here. So this ratio here would be equal to what ratio using those corresponding sides? 38 over y. Okay, so since I started with the larger triangle, I have to again start with the larger triangle. Then I went to the smaller and to the smaller. Okay, so I can cross multiply again here. So I have 32y is equal to 16 times 38, which is 608. Divide by 32. Y is equal to 19. Okay, does that make sense setting up those proportions? They have to be corresponding sides. So if you start with the large triangle, you have to start with the large triangle in the second ratio. Okay? All right, so we are going to practice a little bit more with this. I'm going to add one more thing. So the scale factor, shh, quiet please. The scale factor is the same as the ratio of the perimeters. Okay, so if I asked you to find the perimeters of these triangles that we just went through up here, you could first find this scale factor, which was 32 over 16. So you're using your corresponding sides to find that scale factor. And then you could find one of the perimeters in order to find the other. So that's what we're going to do in example 4. So if triangle DEF is similar to triangle GHJ, we want to find the scale factor of triangle DEF to GHJ and the perimeter of each triangle. Okay, so scale factor, I'm going from DEF to GHJ, meaning DEF has to be the number on top in my ratio. So I'm going this one to that one. So I want to look for which ones are my corresponding sides here that I'm given. Well, I have EF and HJ in this other triangle. Those two are corresponding sides. So I can write out my scale factor from DEF, which is 8, to its corresponding side, HJ, which is 12. Now, since it is a scale factor, I do want to just reduce that fraction. Okay, both divide by 4. So I get 2 to 3. Okay, so next what I want to do is find the perimeter of triangle DEF. Okay, well, finding the perimeter, I just add up all 3 sides. So I just take 10 plus 12 plus 8. So the perimeter of that triangle would be 30. Now, what I was talking about before when I was talking about what was in here with its perimeters, I can use this scale factor and one of my perimeters and use a variable for my second perimeter to set up that proportion. So since I don't know these other 2 sides, I can't just add them all up together to get that perimeter. However, I can take the scale factor I found, which is 2 to 3. Since 2 came from this first triangle here, I'm going to set this equal to the perimeter of this first triangle, which was 30, over x, where x is going to be the perimeter of that second triangle. So the ratio of your perimeters is the same as your scale factor. Okay, so you don't have to go through and solve for both of these sides and then add them all up and put more work on yourself. You just use that scale factor, one of the perimeters, and then you can find the other just solving one proportion. So from here, I'm just going to cross multiply. So I have 2x is equal to 90. If I divide by 2, x is 45, meaning the perimeter of that second triangle is 45. Okay, questions on example 4? All right, then looking down at the bottom, it's just a couple more practice problems where we are solving for x. So each of these polygons are similar polygons. So we can set up a proportion of their corresponding sides. So in number 1, if I'm looking for x, I need to use this side here, right? What's this side's corresponding side in the other triangle? 18. So if I start with this one, I have x plus 15 over its corresponding side, it's 18. Okay, that's equal to, now I'm not going to use 36 because its corresponding side isn't there. Okay, so I am going to use 40 over its corresponding side, which is 30. From here, I just need to cross multiply. So I have 30 times the quantity x plus 15 is equal to 18 times 40 is 720. Now I wrote it like this because I want you to remember you need to distribute that 30 to both terms. Okay, so I end up with 30x plus 450 equals 720. Okay, then we subtract 450, and I'm going to come up here. So I have 30x is equal to 270. Divide both sides by 30, and x will be equal to 9. Okay, so again, when you're setting up this proportion, make sure you're setting it up with its corresponding sides and it's equal to the other corresponding sides. I want you guys to try 2 and 3. At the bottom there. Numbers 2 and 3.
I like the one where they hire the Asian guy.
Please make sure you're doing numbers 2 and 3. Set up that proportion. Solve for X.
One of the songs that at a concert, when they went to work, it's like completely different from what they do. Like I like what they do. I was not nervous because like I was like a couple people that work there, and now if you look at the relationship I have with my coworkers, I get it or not.
Hello.
I like a song called Angel Song. Nice, but we don't need one anymore. I don't know what I have next week. Oh my gosh. Oh, math was terrible. I already did something.
All right, I'm going to start going over these so I give you some time to work on your assignment. Number 2, I'm looking for X, which is this side here. Its corresponding side in my other polygon is this one here. So I can take 4.5 over X, set it equal to, since I'm given 10 in this polygon, I'll have 10 over its corresponding side, which is 5. Okay, then I just need to cross multiply. So I have 10x is equal to 22.5. When I divide both sides by 10, I get x is equal to 2.25. Okay, make sure you are lining it up correctly. So if I started with 4.5 here, I need to start with 10 here. Okay, and then number 3, my x value is down here. Its corresponding side is 24. So I can take x plus 1 over 24. Those are my corresponding sides. Since I started with this one, I need to start with this one again. Since I only have this other side here, I need to use its corresponding side, which is 12. So I can write 12 over 18. And then again, we're going to cross multiply. So we have 18 times x plus 1 is equal to 24 times 12, which is 288. Again, I need to distribute this 18 to both terms. So I have 18x plus 18 is equal to 288. Subtract 18. I get 270. Divide by 18 then, and x is equal to 15. Okay, so when setting up those proportions, make sure you start with the same polygon in each ratio. Okay, they're equal ratios. So if you start with one, you always have to start with that one. Okay, any questions?